First, let me start the computer. Okay, let me know, guys, what we done in the last session. Look into your books and tell me what we done in the last session. Look into your books, guys. Go back to your books, notes. So I think we were working with Docker version command, right? And thereafter, we were trying to understand how to do a Docker pull. And in this, we came to know how to get an image or library downloaded onto our machine. And also, we came to know how to download a specific tag, right? Specific one. The next thing is we were trying to focus on how to check the containers. So Docker images command will show you all the images. Then I guess we saw Docker ps-a command, which will show you both the containers which are live and exit. And we experimented Docker run command. And we came to know about Docker stop also. Am I clear? So yesterday's class, how many of you guys have practiced this? Please let me know in the chat or raise your hands. Did you put your efforts to practice? Don't create any backlogs. So keep in mind, if you want to claim that you are a DevOps, Linux, Git, Jenkins, Ansible, Docker, Kubernetes, like 5 fingers per your hand. This is one of the core elements for your DevOps. Okay. Fine. Now let's proceed from there. So let's see what's next. Well, we saw what is the next thing. We'll go in an order so that we'll not miss any command. Okay, we're done with the stop. Then we'll see the start. Okay. So let me get the machine onto the network. So it is 10. Is 192.168.1.10 root. Yeah. So we got connected. Let me increase the font size. Yeah, we are here. So Docker images, these are so these are the images that we had. Let me try to pull. Yesterday we had Ubuntu problem, no? So let me pull Ubuntu. Okay, still there is some problem. You can take it light. So clear the screen. So Docker ps-a. So these are all the containers which have been exited or stopped yesterday. So we'll start practicing with this now. Now, if the container is sitting in exit mode, it means that it has been stopped, right? It is not working now. So if you want to start this container, then you have to use something called Docker start command. So Docker start, thereafter you can use the container ID or you can use the name. It's up to you. So generally I prefer to go with ID. So I copy the ID from here and put it here and press enter. You can see what happened. What happened? So let me check the Docker ps-a. See, up. It has been made up since 8 seconds. Clear? So container became live. It is up since 8 seconds. That is how you start your containers, guys. Now, once it is up and I want to go into this container. Now, generally, this is one area where students make a mistake even in the interviews. So you have to listen to the question very properly and then answer, guys. If there's somebody says, how do you create the targeting create, then it is Docker run. So if they say that, how do you start a container? Then you have to say Docker start command. Okay. If they say that if the already container is existing and it is in running mode, and I want to re-login into the container, or you want to access the container, re-login into the container. So you need to understand their English, what they are talking. So if they want to re-login into the container or access, get into the container back, then there is a command called docker exec. Now, generally the students make a mistake of answering in the interviews as Docker run. So please, you guys don't do that mistake. So that's the reason I'm stressing. So these are some common areas where we do make a mistake. So if it is create, Docker run, if it is start, Docker start, then re-login into the container, you have to use exec. So you have to be careful. Then next, let's see. My target is to get into this container, guys, into this container. Then what I would say, Docker exec -it, and then type container ID. And I want to talk to it via bin bash. That's it. We got back into the container. Now, did we create any container, guys, or did we logged in back into the container? Tell me, did we create or logged back? Did we create exec? Never, it will never create any container, guys. Keep in mind, exec is only to access the containers. Okay, the similar command exists in the Kubernetes also. So in Kubernetes also same logic. You have kubectl exec command even in Kubernetes. So in entire Dockers, whether it is Kubernetes, if you see a word exec, that's to log in into the containers. Okay, just keep that in mind. The next, please check down this command quickly. So to start, this is a command, and to log in into the containers, this is a command. And this was one of the questions that I faced in my interview in the current company where I'm working. So this was one of the questions that I faced in my interview on Dockers. So which was super easy for me. Being as a trainer, these are all easy questions for me. Is it done? Shravani, is it done? Anuja, Arun, Atif, Divya? Okay, so I see people have done. Now, there is one more command. There is a second method, guys, which you can do the entry also. Okay, I'll show you the second method, but generally people may not be aware of this. So this is a second method, which is not popular. Okay, exec method is so popular. So I'll pick up one example to do this. So Docker ps-a, so or I came out of the container. So let's say I am targeting last one, guys, this one. So my target is to start the container and also get into the container. Okay. So start and get in. Both should happen in a single go. If that is the case, then you have to fire this. Docker start -ai option you need to use. Same Docker start command only, but AI option you need to use and tell the container ID. That's it. It will start and will get you into the container. You see it? I went into the container. But keep in mind, if the container is not running, Docker exec is not capable of allowing you to log in. So Docker exec, whenever you're trying to fire, please make sure that the container is in up mode. Then only you should use that. But when you talk about a start command -ai, even if it is sitting in exit, because basic purpose is to start and then get in. So there's a second method where you can try to lock in into the container. Are we clear on this? Nayak, Kavya, please write this use case, guys, quickly. Kirti, Shravya. Okay, so I'm typing exit. Then next. So how do you change the container names, guys? Okay, so one more. So let's say Docker ps-a. So let's imagine that there are, okay, let me decrease the font size, otherwise table looks dirty. Okay, now it is looks nice. So let's say container is, I mean to say Docker is creating some automated or based on algorithm, it is creating some crazy names here. And if you are willing to change, or if you have desire to change these names, then there is a command available. We call that command as Docker rename. Docker rename, put the old name, okay, and just give a new name. You can say AP or AP, and you check. You see it got renamed as AP. So let's say this one I want to change. So what I should do? The same. Docker rename. Always put the old name first. This is the old name. And just give a new name. Let's say TS. Done. Docker ps-a. So this is how you can rename the containers, guys. Now, second question comes is it possible to rename the container ID? So what will be your answer? Quick guys, you need to give me the answer. Is it possible to rename the container IDs? So please write this question and answer. Is it possible to rename the container IDs? The answer is no. Okay. Is it possible to rename the image IDs? The answer is also no. So anything with the ID stuff, we can't do anything because that's a unique and there is no option to rename. Clear? And alternate counter question, can you rename the container names? The answer is yes, we know it. Can you rename the image names? The answer is yes. So it is possible if it is names, but not the IDs. Okay. So that's the reason we are not practicing on IDs. We only practice on the names. Now, one more interesting question. So let's see. At the time of, see guys, I have a couple of images here. Now I'm going to create one more container out of CentOS. So I'm creating it, just see. We know it, Docker run -it, and we'll put the container ID and we'll decide with what terminal you want to talk. This is normal. We know it, yesterday we practiced. But there is an option called -name, guys. -name tag. So here, instead of automation creation of the names, or we can say based on algorithm, it is creating some names now. So I don't want algorithm or algorithm oriented names there. I just want to create my own container names because you have the control on the names. So you can do that, but not on IDs. So at the time of birth of container itself, we are deciding a name for it. So let's take it, let's this as India. Okay, I've chosen a tag called -name India. It is done. Come out, exit and check it. You see, a container got created. This is a container we just now created, exited 2 minutes ago. The name is India. Okay, so please take down this command. So in the Docker run, there are a lot of options are there. So this is one of the options. We can name a container. Is it done? Okay, nice. And then so rename. Okay, fine. Yeah, this also we saw. Now this is one question. See, the name is nothing but. So at the time of creating the container, if you use a name tag and if you give some name for it, the container will get created with that name. So that's the use of name tag in the Docker run command. So that's the answer for you, Divya. Okay. The name. Next question. So what are the limitations of creating the container? So generally, n, that means infinity, n number of containers can be created out of an image. But in general, if you want to talk about its limitation, so we can say the limit of creating the containers is decided by the RAM capacity. As long as RAM is cooperating with you, things will work. So when the memory is full, as you know it, we'll get the errors. Likewise, the capacity also is decided by the hard disk space, because on the machine also you need to have enough space so that it can host its stuff. So this is general limitation. The next question comes is, how do you delete a container? So let me clear and show you. So let's say, how do you delete a container, guys? So please take down. So let's say I'm planning to delete, imagine this last one. Okay. If that is the case, Docker RM is a command. Docker RM. So whenever you apply the Docker RM command upon a container, please make sure that the container is in exited mode. It should not be in up. Okay. So make sure that it is sitting in exited mode. So is it currently you can see it is sitting on exited mode only. So that's the reason I'm directly firing the RM upon this container. You can use container ID or a name also. Either one you can use. Either use ID or a name. So now check the sheet data. It's gone. It's not there. You can see. Earlier there were 5. It's gone. CAP is not there. Now what happens when you try to delete a container which is live? So let's say the second one is live now. It will not allow you to delete. You'll get an error message telling that it is currently in use. If you read that message, it is trying to tell you that please stop that container and then delete it. Okay. So the process is, a running container cannot be deleted unless you stop it. So you stop this container ID and then fire the delete command. Or you can apply the force technique. That means -- force tag you need to use. But generally we don't recommend to use this because there are chances that data might get corrupted. So better avoid this force technique. Officially stop the container and then delete it. Still force technique will work, but that should be a last option. So it's gone. Okay. So force technique should be a last option, guys. You should officially stop and then delete the container. So please take down this transaction quickly. So Mayuri, Maunika, Nagireddy, are you following me, guys? Okay. Okay, nice. Now there can be a use case that where you want to delete the multiple containers. So simple logic, Docker RM, you put the first container details, then give a space. Don't use the commas, guys. Don't use the commas. You need to give a space, put the second container details, put the third container details or a fourth container details. Okay. So this is what you need to do. So container 1, container 2, separate them by spaces. Don't use commas. Generally, we have a habit of putting commas, but in the Docker subject, please don't use commas. Okay. And next thing is, Okay, so there is one command. What if you want to delete all the containers in a single go, then you should apply this command. But this kind of use cases will never come in real time, so nothing to worry. But generally, you should know the command. So in a real time, you'll never get an opportunity to delete all the things in a single go. So that will not happen. But this is a command they have given. So let's say there are 200 containers are there. And if you want to delete in single shot all 200, then you need to fire this command. So Docker container prune command, guys. Okay, so please take down this. But in a real time, you'll not get this opportunity to do it. Because generally, we don't delete all containers in a single go. That is a command Docker container prune. Okay, the next thing is how do you delete a container image? So this can be an important for the interview perspective. The reason is there are some subsidiary logic oriented questions here. So wherever you have some logic oriented question, high chances are there that they can ask you. So let's see the list of the images. In total, how many images do you see, guys? Count them. How many images do you see? 5 are there. Okay. So I'm planning to delete the first one. Okay. So let's see. The command is docker rmi. Docker rmi. Give a space and put the container image, image ID or a image name. You can use anyone. Preferably, I'll use the image ID and press enter. It got deleted. So now let's check. Now how many 4 are there? Now let me go ahead and delete even the second one from top. This one I'm talking about. Okay, I'll try that. Docker rmi. It's also gone. Now how many images you have? 2. Now let me try to delete this one also. Okay, so let's see. Docker rmi and this. This is also gone. How many images are there now? How many, guys? How many? Only one. So let's try that. So Docker rmi and put that container ID. Now this is not getting deleted. Reason? Any reason for this? So this looks like an English movies, guys. English movies, you will see now some mother parent parasite will be there, and hero will be trying to fight with all child parasites. Huh? Okay. Then somebody will tell him, no, don't kill the child parasite. Just go in and kill the mother parasite. All child gets automatically killed. Makes sense? Some English movies, same logic. So here what is happening is the parent image is not able to get deleted here because the message is super clear. It is telling you that there is some container called so and so. Sorry, this one. So it is unable to get conflict because image is being used by some stopped container. So there is some container created out of this image. That is the reason. So let's check it details. We need to find, see, yeah. So it is telling 5796. I'm talking about this. So this container, or in fact, all the containers here, whatever you see on this screen, 3 containers are there. All 3 containers are evolved out of this parent. So that's the reason it is not allowing. Okay. So now let's go ahead and delete now. There is also force technique. RMI. Okay. Put the image name. You see what I'm doing, guys. And then say force. It's gone. Okay. Now you see the images. We don't have any image, but you check the containers, you still have the container. Now the question starts. We deleted the parent image from the mission. Do you agree? Containers are still there. Yes or no? We deleted the parent guy, but containers are still there. Now the question is, do you think the childs will work? Yes or a no? Or do you think the containers evolved out of it? Are they going to work? Or will there be any functionality problems? Or do you think what could be the situation, guys? Do you think they will work? Yes or a no? So the answer is yes. Because containers, when they evolve out of their parent, I told you, there is one fundamental point even in basics. I told you every container is independent. Don't forget that point. Container is independent. Once it has taken birth, it is independent. That's it. No relation with its parent. Gone. Cut off. Clear? Understood, guys? What I'm telling you. So once it has came out, it's highly like an independent guy. So you can try it. You can start and see whether it functionality impacted or not. We can say Docker start and see the container ID and check whether it is reacting. Yes. Docker ps-a. It is up. See, there is no functionality impact at all. Clear? So this is one subsidiary question you might face in the interview case. So they will create a situation like me only. From the image, I created containers. Containers are live. I have deleted my image, parent image or container image. Do you think will there be any functionality impact on the containers? The answer is no. Okay. Fine. So please take down this situation quickly. So the command is docker rmi and put the image ID or image name. And if you want to delete forcibly, you can apply the force technique. Okay, the next image tagging. Next concept is image tagging. Okay, so image tagging is also again very area of important question both for working profile. Generally, we face this. It's important DevOps knowledge also relevant to a lot for the DevOps. So what is this tagging concept? So first of all, tagging concept is only applicable upon the images. So don't apply this logic on containers. Okay, containers does not have any tags concept. So forget about the containers. Okay, you need to apply this concept only on the images. Now taggings are of two types: local tags and remote tags. Local tagging process and remote tagging process. So whenever an image, okay, whenever an image, whatever the image that you have with you, and if you create a local tag out of it, what happens is it creates a copy of reference on your local machine. Or we can call this as a kind of a shortcut, guys. See, in Windows, you had knowledge. Do you have the knowledge of Windows shortcuts? In Windows, let's say there is an application. We create a shortcut, right? Are you aware, guys? In Windows operating system, there is a mechanism of creating a shortcut for any applications, correct? Yes or no? Are you aware of it? Yes or no? First of all, tell me. Otherwise, I'll show you if you're not aware. Yeah, most of the guys know it, so I'm not worried. Okay, so shortcut mechanism of what you see in the Windows shortcut mechanism. Okay, for example, let's say I want to create a shortcut. What I would say this application. Okay, or let's say this one. I'll use calculator, that's fine. Right click on the application and you just say, where is this? Windows Start, more. We don't have a shortcut for this. Why? Well, let's try this application. Right click. I think you guys already know this concept, what I'm talking. So let's say this one, right click, create a shortcut. This is what I'm talking. What happens when you create a shortcut? You tell me, guys, what is exactly happening when you create a shortcut? Is it creating a copy or is it just a referencing? It's only a referencing, correct? Exactly the same story. Okay, it's like an hyperlink or referencing, correct? So the Windows concept of shortcut is exactly somewhat to the logic of local tags. So whenever you have the image and you downloaded it onto your machine, and once you have it, you create a local tag. It creates a reference of that image on your local machine. So I'll show you what happens. So let's see. And whatever the images that are created out of local tag process, these guys are not eligible. See, these guys are not eligible to upload, or that such an image which has been created out of local tag are not eligible to upload into Docker Hub. This is a very, very important point. An image, if created out of local tagging process, then such images are not eligible to upload into the Docker Hub. So let's try that. Clear? Do I have any images here? I don't have. So what I'll do, I'll create one. I'll say Docker CentOS, full CentOS. To experiment the subject, I'm getting one image. It's there. Now Docker images. You can say I have one image. Now I want to plan to create a tag for this. So what I'll do, local tag I'm saying. So I'll say Docker images tag. I forgot the command. I guess tag is a word you need to use. Yeah, tag. Then give the name. Okay, use a name or ID. It's up to you. Use a name or ID. So I'll use this name. Okay, copy. And I want to create a copy of this image or a reference point or a tag of this image on my computer as 3rd March underscore CentOS underscore local tag. Just for our reference, I'm creating. Press enter. What is he have? So you can see here 3rd March. So and so image created out of this tag, correct? And image ID is same. And it has been created or updated 17 months ago, same. So both are like same, but this guy is an original one and this guy is an referencing point. It's something like a shortcut we created or something like a tag. Now, why we use the local tagging is generally in the coding, the team does not want to expose the original name. That is the reason they alternately create some names and use it in the images. Got it, guys, what I'm talking? So normally why we use this tagging? This taggings can be in referencing. They want to create a referencing images names for the so-and-so images, and they start using that reference names in the coding process. So that helps to hide the actual image name. So this is local tagging process. Now, how to go with the remote tagging process? Remote tagging, guys. To experiment the remote tagging process, the first eligibility list is you need to have an account with the Docker Hub. You need to have an account with the Docker Hub, guys. So to experiment the subject of remote tags, please create the Docker Hub ID. So this is exactly almost same to your GitHub. So like you've done the GitHub account creation now, just go ahead and create that does not require any like special training for it. So just open up the Docker Hub. Like you create your Facebook or Twitter accounts, just simple, normal. Go to this and click on register and choose some Docker ID. Provide your email ID, provide the password. That's it. They only want these three details, guys. They don't trouble you taking all your biodata. They just want your name, username to be selected, email ID, password. And I am not Robert, selected, agree. And you'll get in a confirmation mail to your email. Just accept it. That's it. Nothing else here. So I'll assume that you guys already have an account like me. I already have an account. Click on sign in. See, I'm using my ID. And I click on sign in and password. Continue. Put your ID and password. That's it. You logged in. So this is how the Docker Hub looks like. Your IDs, your account. Okay. But keep in mind, in a real time, we don't use your personal IDs there. Our personal accounts we don't use. It's common that in corporate policy, we don't use personal accounts. So in corporates, what we do, we just go ahead and use our, what we do, guys? So in corporate world, we just use a company ID and password. So they'll share the ID and company ID and password we are supposed to use. So that is what you need to use. Now to our practice, please go ahead and create your own IDs and passwords. Now I'll assume that you already have the IDs and passwords to you. Now this is how remote tagging process is created. So I'm doing it now, just observe. Docker image tag. Choose the image for which you want to create a remote tag. Let's say I want to go with this. Put that name. And then choose some name. Okay, so let's say again I'm using same 3rd March underscore CentOS underscore, this time I'll say remote underscore tag. To identify that earlier one was a local tag and this was a remote tag. So, but when you give the name here, the logic is you are supposed to start with your ID, guys. Your user ID. So my user ID is Tumu Vikram. I'll start with this and put a forward slash. That is the format you need to follow. So when you know that you want to create a remote tag process kind of an image, so please, only one difference is in the naming convention, you need to start with your ID, put a forward slash and give some tag here and then press enter. Now check it. You got the remote oriented image ready. So an image which starts with an ID is like this. See, docker.io, right? Tumu Vikram forward slash show. Any IDs that start with some Docker Hub ID, they are eligible to upload and download. So they're part of like incoming and outgoing process. But an image which does not have initially started with some ID, they are not eligible. So that means this image local tag will always stay on the computer only. And this guy is capable of traveling onto the remote server. So I'll show you how it travels. Now the next most important thing is after the tagging is completed, you need to do, my target is to upload this image into my account, guys. So I'll show you how to upload. So this you should do only after tagging is completed. So tagging is done. Now my target is to upload. So I'll say Docker login is a command. So enter your Docker ID and enter your Docker password. Okay. Hold on. I typed my. This is also wrong. Hold on, guys. I forgot my password. Just I need to check. I'll check it on other side. Hold on. Give me a minute. I need to check in my password stuff. What I gave. Okay. So I saw my password. Now let's try. Same. Docker login. Enter your ID. Then I'm entering my password. See, it will say login succeeded. Do you see that? Confirm. Do you see that? So once it says login succeeded, that is where you have to proceed now. Okay. The next step is to say Docker push. That's it. Docker image push, guys. Docker image push. And whatever the image that you want to push, it will go ahead and sit on the Docker Hub account only. So see, whatever the ID that you logged in, it gets connected to that account only. So I got connected to my account. Then say, let's say I want to push this image. When you're pushing the image, guys, please never use IDs at all. I repeat, when you're pushing the images, this is the only command in entire Dockers. In that command, which you're not supposed to use the IDs. Please write that point. Okay. So this is the only command in the Dockers where you're not supposed to use the image IDs. You're supposed to use the image names only. Okay, so this is an image name, press enter. That's it. So this copy will go and sit on the hub. Will take 2 or 3 minutes. Meanwhile, we'll update the notes here. So second thing is create remote tag. Image. Third thing is do the Docker login. And fourth thing is you can push the image. That's it. And last thing is verify whether it got uploaded there or not. Verify. You can do that. So it says it's done. You can see it says done. Now go back to the website and just refresh your account and you'll see that that image will come here. Okay. Third March CentOS remote underscore tag. Just now we done pushed few minutes ago. Got it? So this is how we push the images, guys. So please take down this process. Process is more important. Generally, they will ask you the process, guys. How do you push the images onto the Docker Hub? So whenever you're trying to upload an image into the Docker Hub, so please make sure that the image has remote tag. Only such images are eligible to upload. So create a remote tag for it. Then do a login, then image push, and then verify. Now, these are the very careful things you need to be aware. So this looks very, very interesting. What is this interesting about? So whenever you create a name for the image here, it should not start with a number. Okay, some students, what they do is they will try to create an image name with their telephone numbers. So no, an image name cannot start with a number. And image name cannot be a single character. So don't start the image name with, let's say, 123 India. It will not work. If it is India 123, again it will work. Are we clear? Rajat, Pavan, Bhagat, Rudviraj? What happened to the voice? Is it good? Can you hear me, guys? I think voice is fine, no issues. Others can hear. Okay. Then next, this all I just now I told you. So you need to do the login. You need to create a remote tag. Then you need to push the image. That's it. Okay. Once the push is over, you need to do a logout also. Once the work is over, guys, just do a Docker logout. So it will exit out of that login. So login, Docker login, push. Once the push is fine, then logout. Docker logout. The next, most important next one is, how do you get the image metadata information? So what is this metadata information? So metadata information is nothing but looks like when you buy some medicine, what you will do? Some people have a habit of checking its chemicals. Do you agree? What chemicals are present in that medicine? Am I right, guys? Yes or no? Compositions. Generally, we call compositions. So we want to see how much configuration or how much composition is there. So that means you're trying to check the properties or attributes of that medicine. So likewise, so when you buy a laptop, generally what we do, we go ahead and check its configuration under system properties, correct? Likewise here, we go to the system information and we'll see all the informations, right? What kind of hardware component like this. Likewise, if you want to see the in-depth or in detail about a container or an image, you have to apply the inspect command. So whatever the details it is showing, we call that as metadata in Dockers, or in, let's say, in generic style, we can in a normal layman language, we can say this is nothing but properties or attributes, or in simple words, details. But technically, if you say, we have to say metadata. So let's see what details we'll get. Okay. So we can apply this command both on images and containers also. First, let's try on image. So I want to see the properties of this image. Okay. So what I'll say, Docker image inspect. Inspect. And give the image name here or container ID. Sorry, image ID. So it is showing you a lot of details. Got it? So it started from here. It went on to here, right? Lot of details are present. So generally we look into the inspected details for some reason. So we want to check how many, you can see the tags, you can see it here, how many tags are there. And you can see its details, where the volume is configured, where it is operating, okay, how many containers are created out of it. All those details will be there here only. So under, see, only one container ID, right? So here you'll have the tags and here you'll have the container details. So this is a general information. Correct. So this data you will see in the form of this, whatever the data that you're seeing, this is in the form of JSON actually. The details that you see on the screen, guys, this is in the form of JSON. Okay. I clear the screen. Now let's say I want to try the inspect command on container. So I need the container ID. So I'll say, now let's try Docker container inspect now. Earlier we said image inspect. Now we'll say container inspect. And we'll use some container ID. So let's say I want this present. You understood, guys? So this is a difference. Okay. So we said container inspect so and so details. So these are all the details of container, not the image. Okay. So it will contain its RAM, CPU utilizations and everything, whether what kind of IP it is. See. So if you want to see the IP address of the container, it will be here. Somewhere around here. Hold on. Name that is not yet. So this image has been simple. So we'll see the practice when we are doing with the images with, I mean to say containers with IP space. So as of now, it is not created with IP, no port config. That's the reason no IP address here. So which image did we try? First of all, if it is down, it will not show. What is this image? 6FF. Okay, it is exited. Wait. So let's see the details of the live one. Okay, then we can see it. It is down now, so there is no details. So exited one, if you try, you will not find any IP address, but let's see the live one, then definitely you should see the IP address. So we'll say Docker container inspect this one, because this is live press center. Yeah, you can see the IP address details. See. So networking settings. So you will find the IP address is this. This is the IP address of the container. And it's a default gateway is this container IP. So that is how you can find the detail. Generally, we'll use this to find this details. Okay, so that is the use of this commands, guys. So image metadata and container metadata. Now, next command is very important command. So this is where the third level of knowledge is coming into the picture, guys. High degree, next level. So this leads to the programming side actually from here, or you can say coding parts will start. So how do you get the image history? How to get the image history, guys? So what is this image history stuff? I clear the screen. So Docker images. So Docker image history. History commands should not be fired on the containers. History command should be fired only on the images. Okay, Docker image history. And for this image name or ID, it's your choice, and press enter. So you'll get some details. See, you got some details. How many details you have, guys? How many lines are there? Tell me. How many lines are there? See, you got some data, but you need to tell me the lines. 3 lines are there. Okay, just keep that in mind. Now I'll fire a Docker pull to experiment the knowledge and wanted again downloading Nginx. Spelling mistake. EGNIX. Okay. INX. It is downloading. Now it has done now. You can see two images are there. I meant to say Nginx is also came in. I'm firing the same command on Docker image history upon this one and press enter. How many lines you got it? Count them. You need to count the lines. Okay, I guess you guys have counted the lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 lines are there, right? So why you think the CentOS has shown the 3 lines and why you think this is showing 15 lines? Any logic here? No, it is not releases. So basically, this history command can help you indirectly understand, not direct, indirectly understand how much of code of lines has been written. So CentOS is showing 3 lines. Okay. That means on an average, rough estimate, guys, it is not exceeding 3. So definitely I can say that 3 lines of code is written. Okay. Now Nginx. How many lines we saw? 15 lines. So that means I can understand that on an average, it is 15 lines of code has been written. The question comes is, where do you think this code has been written? Where, guys? So this code will be written in a file that is called as Docker file. D capital F small Docker file. And here also, this code will be written in a file called as Docker file. Okay. Now, if you want to see the actual code, what you should do? Apply the common sense and tell me, guys, if you want to see the actual code of the CentOS, what you should do? Actual code. Just apply the common sense and give me the answers, guys. This does not require a super engineering stuff here. So if I just want to see the actual code of the CentOS, what I should do? I should have the access to the file of Docker file and I should open that file and see. Do you agree? No, that's the simplest logic. If I want to see the actual code of how the coding has been written, then I should open up the Docker file and see how it is written, right? So imagine if this file is been not given access to you, then if there is no access to this file, then how come you will know how much lines of code is written? The answer is nothing but history command. You got it? This history command only. This history command is helping you to understand how much code has been written. That is not direct, only indirect style. But whatever commands are written, that you will know. How come? Because in this output, it will show you all the, see, this is part. These are all part of coding. All this. Anything that starts with capital and thereafter small case. So these are codings only. Here also, in this earlier use case, capital. See. You understood? So that means CentOS on an average 3 lines of code is there, and this is on an average 15 lines of code is there. Now, you need to understand one more point here. So let's assume that Docker file they have written. So once they have written, they will undergo a process. They need to execute that. That process is called as Docker build. Okay. The command itself is also a Docker build command. Command is called Docker build. If that build command executed perfectly, or you can say if it is positive, then the image gets created. If the command or execution fails, image will not generate. Understood? So normally what happens is, once the image has been generated, right? From this, we create the containers. Now, normally in the projects, what they do is, once the image is with us, you can create the containers. They will try to lock this Docker file. You know the reason why? They don't want you to edit further. They will lock it or they will hide it. So this is normally happens in projects also. They will lock the Docker file because already image is given to you, and you from the image you can create containers. So containers are created from the image case. Containers are not created from Docker file. Docker file execution output is image. From the image you create containers. So once the image has been ready, the file can be locked, which contains the logic of creating the image. So that is the reason alternative method is we have to apply the history command. Am I clear on this? Am I clear so far? I want to tell you one more after this, which is more interesting than this one. Okay. Now let's take an example. Let us take an example of some image called XYZ. In that image, we see the Docker file. I can say the Docker file contains 4 lines of code. 4 lines of code, guys. Okay. Now, first line. Okay. Some code is there. Second line. Some code is there. Third line. Some code is there. Fourth line. Some code is there. Right? So first line, fourth, second line, third line, fourth line. Now, next level. Again, in the each line, how the code is written is, you will have a format called capital X and small y. So capital X is nothing but the instructions. Like in Ansible, we used the modules. Like in Chef, we will use some resources. Like in Jenkins, we used some plugins. Likewise here, we'll use something called instructions. Okay. The instruction is written in capital and its value is written in small case. Example, you can see on this screen. See, copy is written in capital, its value is written in small case. Entry point is an instruction which is written in capital, its value is written in small case. Expose is written, this is also an instruction and its value is written in small. So the overall story is the instructions which are written here. So using the instructions only, you have to develop the logic of the Docker file. These instructions, luckily, they look like Linux commands. That is another advantage. So that's the reason I told you in the beginning, the people who are very good familiar with the Linux, they can play with the Dockers and Kubernetes a lot. Because commands of this look like Linux commands on. That is the reason. So if you are these days, I think a time has come to replace. Can you hear me now? Okay, I think a time has come to replace my headset. I'll replace sometime tomorrow, guys. Okay, so let's say this is capital B and I'll let some value. Okay, I'll write like this. I'll use capital C. Whatever in capitals I'm writing, that is a command and its value will write. So this is how, guys. So line 1, in each line, we only use one instruction. That is a generic rule. generic rule is one instruction. So it used one instruction, second instruction, third instruction, fourth instructions. Now, if I ask a question here, how many instructions did I use in this coding? How many? 4. Okay. Now, after writing this 4 instructions or 4 lines of code, I'll go ahead and save this. Imagine everything you need to imagine now. And then I'll go for Docker build process. So I told you now, after the coding has been written, next step is Docker build only. I'll apply the Docker build. So when the Docker build has been applied, the computer goes and checks here whether the first line has been written correctly or not. Okay, that is the role of the Docker build. Docker build will check whether the coding is written correctly or not. So if it is a positive, I would say success, then it will create something called layer. And it will, along with layer, it will create something called hashtag. Hashtag. Or it is also called as commit tag. C tag or hashtag or commit tag, alternate names. Now, this will only create if that line is written correctly. So this is also positive. This is layer. Now, you need to remember this layer is called first layer. This is called second layer based on line numbers, right? So this is third layer. And this is fourth layer. You understand? So each line it checks. If it is positive, it will create a commit ID or commit tag or hashtag. Then it will create a layer. And that layer is classified first layer. Then it goes to the second layer, second line. Same logic applies. If it is success, it will create a layer. Now, likewise, unless all the lines in that file, whatever you have written, if all the lines are good means if everything is positive, then only it will create the image. That is the principle here it follows. Imagine, so far third layer is also good. That's the reason it created third layer. It went on to the fourth layer, it failed. Or let's say fourth line, it failed. Are you expecting the image to be created? Tell me, guys. No, it will not create any image. Okay, next question. While it was executing, it failed in the first line. Are you expecting to create an image? Are you expecting this? No. So the simple rule is whatever the lines of code that you've written, all the lines have to be perfect. So until unless they are good, image may not get created. It will not create for sure. So let's assume this is success. Let's say this is layer number 4. And it will create some tag here, commit ID tag. So whatever tag it is creating, it looks like your Git ID, guys, commit ID. It looks like a Git ID only. So whatever the ID, some number it generates. So whenever your image gets created, whatever the image got generated, it will carry an ID, which is nothing but the last layer's ID. You need to remember this. This logic you need to remember. So whenever, if all the lines are perfect, image will definitely create. Image needs to have some ID, and that ID will be nothing but the last layer's commit ID will become the image ID. Now keep this logic in brain and apply here. You see? So this is the first line. See, when arrangement of the image, it is reverse, guys. So what happens is, let's say this is an image. Imagine this is an image. In this image, layer 1 will sit. Upon the layer 1, layer 2 will sit. Upon the layer 2, layer 3 will sit. Okay. Upon the layer 3, layer 4 sit. So you need to remember all these logics, guys. first line of the Docker file, okay, will create the first layer. Second layer of the Docker file or second line of the Docker file will create the second layer. Third line of the Docker file will create the third layer. But in the order of the image, the first line will sit at the bottom. That is, this is the base bottom. Upon this layer 2, upon this layer 3, upon this layer 4. Okay. Now what happens is when you fire the history command, actually it is showing the layers only. So that is the reason there is a definition, another definition for container image is it is said that container image is a collection of layers. This is another definition for container image, guys. Container image is nothing but it's a collection of layers. Do you agree now with the explanation? It's a collection of layers. Rahul understood? So container image is an outcome of Docker file only, right? If the Docker file, each line gets executed perfectly, then layer is getting generated. So this collection of layers are actually forming your image. So that's the reason container image is also classified as it's a collection of layers. Now apply the, go back to this. Now, if you apply this logic properly, that means when you're looking at the history data, should you look from the top or you should start from bottom, guys? Tell me now. If you are looking at the history stuff, will you look from top or will you look from bottom? Rohini, what will be your answer? Since you understood this concept, what I'm trying to tell you, now you have to apply some little mathematics or aptitude here. Tell me, when you get the history data here, will you start looking from bottom or will you start looking from top? You should look from bottom because bottom will be the first line. This is means second line, third line, fourth line, fifth line, sixth line, seventh line, eighth line, ninth line, 10th line, 11th line, 12th line, 13th line, 14th line. Okay. 14. Now, in this 14th line, the 14th line is containing the some commit ID. What is this number? You just see image ID. What is this number? 904B something is there now. Just remember first three numbers 904. Now you go ahead and check the image ID. So we are checking the history of Nginx now. That means this one. So what is the image ID number? Both are tallying now. You understood? This number what you got and this number what you see are both will tally. Both will be same. The reason is image ID is generated out of the last lines. The last line commit ID or hashtag ID will become the image ID. So that is a ground rule principles in Docker. Clear? Yep. So this is a simple explanation of your image history command, guys. Now what you will do is we'll try to do one. No, time is up, so we'll try to do in the next class. Okay, but I want you to go and understand this stuff very well. So please try to understand the history. So again, we need to start from history in the next class because we have to write some Docker file there. Clear? Any questions so far? So let me go ahead and put the notes. Any questions, guys? Okay, I don't see any questions. So next thing is you want the class tomorrow. Please confirm. How many of, because tomorrow is a weekend. So just I want to check with you because weekend is always a weekend. So please take the opinions quickly. So far 2 responses, 3 responses. Quick, you guys have to be quick. Only 3 answers I got. Weekend always I'll go by your opinions, guys. Monday to Friday, it's purely my choice. So Saturdays and Sundays, it's your choice. Sunday anyway will not have. Saturday, it's your choice. So it looks like 3:1 so far. 3 said no, only 1 said yes. So those who want the class, please type it yes. Okay, now it is balanced. 4 said no class, 4 said I want class. So it is balanced now. Others also please take part in your opinions, guys. Nothing wrong. Okay, let's learn to like this. So let's take voting. Raise your hands who want the class tomorrow. Raise your hands in the chat. Those who want the class tomorrow. Wanted people. 3, 7, 8. Head count is 8. Head count is 8. Okay, fine. Did I take the last week Saturday class? Did I take? If I've taken last week, that's okay. Then please enjoy your weekend tomorrow. And definitely I'll take the class on next Saturday. So please be ready. Generally, I take 2 Saturdays in a month. So this Saturday I left off. Next Saturday, Pakka, 11th. So get ready. No holiday on that day. So please plan accordingly. So I'm expecting your class will be over by 22nd or 23rd, guys. Okay. 22nd or 23rd, maybe. So what is your estimate? We corrected our estimate now. So 23rd it started. Exactly 10 weeks you need to count. So January, February, 8 over. Yeah. So 9th March plus anyway 7 is extra. The reason is we had the Sankranti holidays. So 9 plus 7, how much? 15th. Okay. Yeah, maybe by 18th we are planning to finish. Here and there 1 or 2 days, not more than 22. So we'll be on time below 18th case. March 18 should be generally the last. Okay, so that's all for the day. And let's catch up on Monday, guys. Please enjoy your weekend. Be happy and come back.